So what's on our menu? We will look at some definition, so we will be on the same page. Also, we look at types of caches that we can use, because I think that there is more than one. We will discuss some benefits, and also I will try to give you some best practices and tips how to start. So, before we formally start, by show of hands, how many of you are currently using some sort of cache in your project? Very nice, more than half. Okay, maybe if there is a half that didn't use it, I still do the boring stuff, so we will quickly look at the basic terms that you may heard during the presentation, so I don't want anyone to get confused. So when I will be talking about data source or data origin, I mean something that you are pulling data from. It can be SQL database, NoSQL database, even API, internal third-party API, even something like, sensor in your environment. It depends on the system you are building. Cache key, I hope that this is the term I don't have to explain any deeper. The cache is some sort of key value storage, and cache key is the way how you can access data in it. And mishit is from my point of view, basic terminology, but maybe someone don't know what it means. If you experience miss, it means that you didn't find data under the cache key you wanted. If you experience a hit, it means that you are lucky enough and find them. So, what is the cache? Don't take this as a formal definition. It's more like my trying to define it and how I feel when I'm talking about cache. For me, the cache is a temporary data store for data that are frequently accessed, or maybe for data that can be reused. And I think the key part of the definition is that cache is faster and probably more cost efficient than original data source for use. So what are the types? Maybe someone will be surprised by the list I choose. I tried to divide the types of caches into categories as I think that they work. So the first one for everyone here, it's a cache for the compiled bytecode translated to the native code that your CPU can understand. And if we are talking about performance, I think it's a crucial thing as well to mention it at least. Another group is probably most commonly called as cache. I think a lot of people, if I ask them, what do you think if I say word cache, it will be probably Redis or memcache or some sort of this. It can be also your own in-memory data storage you implement on your service. So that's another category. In our systems, we are heavily used something that is called reverse proxy. And Nginx and Varnish are the, I think, most biggest names in that category. You will see how you can utilize them to get more performance from your backend as well. If you are globally exposed and you have clients all around the world and you are serving some static data, that's great because you can use CDN. Content Delivery Network is the acronym. And it can deliver data all around the world to your users without any other hassle from you. So I think it wouldn't be complete if I didn't mention it. Even if it's a backend performance talk, I think that if you want to build the most performance system you can, and you have ability to, modify or change the way how the clients or users interact with your service, and add also some layer of cache here, you will get the most of your system. But if you can't, and you can't predict who or how will access your service, some tips will be also applicable for you, but you won't get that great results. And if you are any like me or Lukáš, who's sitting right there, I think you will hate, build times during building any Kotlin stuff using Gradle. So I think it's a great topic if you spend some time tuning up your build pipeline and lower down the time that your build takes. Everyone will thank you for that, at least in your team. That was a little introduction. How can we use that? If you are, how to say it, nice programmer and doing stuff right, you are halfway of winning, because if you build your system in a way that you separate your business logic from the data source, and you should build it like that, it's pretty easy. Because if you are using something like data repository pattern, you can modify your repository in a way that when it interacts with your data source, it can also look the data in your cache. And it's no matter if it's local in-memory cache storage in your system, or if it's shared storage among all your servers. I also mentioned the reverse proxy. I don't know if you are all familiar with. The most common use of this type of technology is that you put it in front of your server, and it acts as a guardian of your little service, and it can help you reduce the stress on it. We will be talking about this a little more, but this topic is really interesting, and I think we have already made several presentations about it, but if you would like to, we can prepare some specific presentation for this community. And of course, if you put everything together, it will work like a charm, and you can get nice results. What are the benefits of using cache? I think it's pretty obvious. I said it many times. It can reduce the load on your service. It can also improve your latency. It can be more cost efficient. It can help you even with scalability, in some cases with high availability. And also it makes your users of your service more happy, because it will be faster, right? So scalability, how we can achieve this using cache. If you can imagine any service without using any cache, I think something about what pulling data from the data source and combining them together, maybe making some transformation to be able to publish them out. And you don't use any cache. You will get direct correlation between what you get on your input, like requests, and what you do to your data providers, right? In that way, the scalability is pretty hard, because you have to scale whole system. You have to scale either your service and also the data sources. But if you think about it smartly, you can implement, in most cases, some sort of cache, and then break the correlation between those two, and you can scale only crucial parts of your system. So in that way, you can achieve a lot with less stress on the data sources. One example can be using reverse proxy also between your services. I think it maybe seems uncommon or wild, but we have service that acts and works like that. And already there are guys that are developing it, and also there is also a presentation about it. I can link it, or we can chat about it more. Also, if we are talking about scalability, how you implement your cache, even reverse proxy cache, is crucial for your scalability. Because let's say you are having one reverse proxy and one service. It's fine, because what the reverse proxy holds in cache doesn't go to the service, of course. But when you need to scale up the reverse proxy side of your whole system, and let's say that you don't have a way how to effectively share the cache between the instances of reverse proxy, right? If you scale it from 1 to 10, you increase your load on the service 10 times. But if you think about this in a smart way and design it as a cascade of the reverse proxy servers, you can achieve only one request again. Because what you can do is to cache the static data on the front part of the cascade, and then let the front side load balance all of your requests and cluster them to all of your back part reverse proxy servers, and then you will achieve again only one place where the cache is stored, and that means that you will not experience as much hits as you would without that. I also mentioned high availability, how you can use cache to help you with that. It depends, right? I think this is based on what you can do with your data, how you would like to present them to your users, and if you prefer having your whole service down, or you would rather present a little bit all the data to your users. Because if your data source goes down, you can implement this using cache in a way that when your data source is unresponsive, or you get bad data, you can't connect it, anything. Nice. Dinner time. So you can implement it in the way that if you experience some errors from your data source, you will rather fetch all the data from your cache and represent that as output of your service rather than having an outage. Of course, it's not long-term fix, right? It's only help you with bridging maybe little hiccups, and maybe a little time, then you will either start another cold backup data source or something like that. It's not permanent fix for that problem, of course. So, since it's too late for us, let's get our blood flowing. Please, everyone, stand up. Like an man. Please stand up. Right. I talked. Thank you. Oh, nice. Good job, guys and girls. Is there anyone who thinks that there is also downside to using cache? You can sit down, please. Oh, only the ones who thinks that.
I'll be fired.
No. And other ones who don't think can sit down as well, because I will show you them, and I don't want to be falling on the floor. So yeah, of course, like everything in life, cache is not any different. Everything has pros and cons. So there are a few downsides that I can think of. The first one is, of course, adding complexity to your system. If you like it or not, if you have the service I described before, something simple that is only fetching data from the data source, transferring them, mixing with some other data, maybe some calculations, and throwing them out, you have pretty much stateless service, right? And as probably many of programmers know, stateless is good. By introducing the cache to your system, you are adding state. Too bad. So you will experience some bad things from it, like stateless data, maybe some cache inconsistency. If you have a lot of layers of cache, it's pretty easy to get into this stuff, and it's not nice, believe me. If you every hit for the same data source, like you are acting as the data source for something else, maybe application, and every hit of it returns different data. Sometimes it's old, sometimes it's fresh. Oh, nice. So yeah, that's not easy. You can, of course, overhead your cache as well. It's not something that's super strong and can handle everything. And if you build the huge system that it's highly dependent on cache and relying on it in peak performance times, it can be pretty challenging to warm up cache during your peak time if something bad happens. And also by introducing another part of your system, you are opening surface for, some attacks. So we need to somehow mitigate those cons, of course. I will show you just the basics again. We can deep dive on this topic if you would like to. So I tried to add each cache type invalidation that I can think of into some category. They have a lot of in common, so we can walk through them and we will see, right? So the first one is time-based invalidation. In my opinion, it's the easiest one you can use because most of the cache engines will handle it for you. Nice. Less work for me. Great thing. So you just set time to live for any cached object, and you will hope that cache engine will clear it out for you. So pretty easy. It's predictable most of the time if the developer of the cache engine software didn't make a mistake, but shit happens. Yeah, that's great. And it's usable for mostly static data, but sometimes you can utilize this kind of approach also for dynamic data, but it depends how much you need them live. If the data is changing, let's say, every 10 seconds, every minute, it can be probably used in that way. Or if your data haven't to be up to date right on time, you can use it as well. If it's not crucial for your system, yeah, go for it because it's easy. Another thing is if you need the data as soon as possible and live, that will make your life harder. The first thing is event-based cache invalidation. You can imagine as, some data is written to the database, maybe reading from some sensor is changed, or I don't know, you will get new data through some message queue, all sorts of stuff that make you change the data on your output. So you create something like event and you distribute it through your system and invalidate all cache upon it. The great thing is if you know the data, you don't have to invalidate data. Invalidate data means that you remove them for the key, and another request that will need those data will experience miss, right? So it won't find them, and it means that your service have to go and fetch the data from the data source. Easy enough. But if you have data when you are creating such an event to distribute, you can be smarter than that and also write your new data into the cache, so there won't be any miss. And the third is version number or hash-based cache invalidation. This is where you are not purging the cache, but you are making the service miss the cache by changing the key, right? So you can imagine it like having a name for the part of the data you are storing to cache and append some part that's dynamic to it. The easiest example could be, I don't know, I want the data to change every 10 seconds, right on spot. Not 5 seconds and 15 and 25, but every 10 seconds, 10, 20, 30. And my cache engine doesn't support that. We can use the thing that's kinda version-based invalidation. So you will get timestamp, you will modulo it by 10, and append this to your cache key. In that way, you will get every 10 seconds new cache key, and the service experience miss. A few tips for you if you would like to start, but a lot of you already started, so I hope I would share something new for you as well, maybe in last parts. Always think twice about what you need. Don't randomly throw cache into your system because you heard that it will help you with your performance, because it will be trash. As I said, it will add complexity, and you as a software developer want it to have as nicer life as possible, as easy. If you would like to start with that, I will suggest to use time-based invalidation because it's easiest one. You will learn how the stuff works, what it will do to your system, how it can help you or can't. So probably I will suggest start with that if you are a beginner. It's easy for static data because they can stay there like forever if it's static. And for dynamic data, that's not that crucial. I would suggest always monitor your performance. I will bet that almost every one of you already does it. But still, I can't stress enough, monitor your performance on your cache as well. You need to see how much memory it consumes, how big is the throughput, like network throughput, and all sorts of metrics. Keep an eye on them. If you can, watch the performance of your data sources as well, because it can give you conclusion if your cache is working right, if you need to implement it more, or if it's irrelevant at all and you are making your life harder unnecessarily. Keep an eye also on hit-miss ratio, because if you have 1 to 0 miss-hit ratio, it means that you haven't hit cache like ever. Why are you using it? So yeah, I experienced this at beginning, so I think it can help you down the road. I think many of you are sitting here and thinking about this question. But what to do if I don't have a cacheable data? My data can't be cached because my every response is different. We had those services as well, but you need to think about them differently. Yeah, I can imagine the scenarios where you can't cache the data. But in most of the cases, you can, but you have to think about the whole system differently. Sometimes you need to fetch more data from the data source, so you will be able to respond to more requests from that big chunk of data. Sometimes you need to do opposite, slice the data into smaller chunks, so you can fetch smaller chunks from cache and build whole response from that. It depends on your use case. So yeah, sometimes you have to modify the system. It's not just only plug and play. Yeah, so it's look like that it's almost done. So to recap the things, I think is important. Cache is not only one thing. It's not only in-memory storage. It's not only Redis. It's wider and bigger topic. And if you would like to build highly performant systems, you should look at it and try to play with it, because yeah, maybe it's scary, but it's also kind of cool if you improve the performance of your service by 100-fold. Sometimes you have to modify your data. You can't use it as is. That happens. Always monitor, because it can help you to decide what to do next, what is important and what not. And try not to request same data twice from your data source. Any last thoughts? Any last words? Yeah, as I said, it has pros, it has cons, but if you will manage to mitigate those cons, it will be very beneficial for your system. That's pretty much from me. Thank you for your attention. Once again, my name is Pavel Cvetler, and as you can already probably say, I'm enthusiast in backend performance optimization. In my free time, I'm kind of also fiddling with IoT, smart home, renewable energy. Also, who not? Large language models and Gen AI. Yeah, this little QR code that look like modeling something is AI-generated QR code with astronaut on it, and it still works. And this one is linked to my LinkedIn. So if you would like to deep dive on any topic I presented today, maybe some of hobbies of mine, or would like to chat about technology, because it's my hobby as well, you can reach out and we can talk through LinkedIn. Also, I'll be here in the evening, stealing from you now, so we can chat there. Once again, thank you for your attention.
I would just like to ask, how did you deal with deployments, like keeping the cache between deployments, any more cache when you restarted the server or upgraded the Elastic cache nodes or something?
Yeah, great question. Thank you for that. Obvious answer, it depends. Sometimes you have to purge your caches, sometimes you don't. The great thing is that you can use version-based cache invalidation for that. We had some deployments where we even using the version-based cache invalidation flush whole cache. It's great, it works, it's safe, unless you are deploying at your peak time, right? So yeah, it depends. I think it's a pretty interesting topic, and we can chat about it later maybe.
any thoughts or approaches about testing? So if you start without any cache, and when you introduce some cache, is it reasonable to create some integration tests
Yeah, yeah.
to check if everything is correct?
Yeah, another great question. Thank you for that. At first, when we start, we were like, hey, it works, right? And it didn't, of course. So yeah, you have some integration tests. The great thing about today's world is that you have a Docker, and you can spin off any instance of whatever you want. So we built some services that are covered even with the cache, so it will spin up cache, also database, fill it with your data. You can check if the invalidation works. Yeah, so it is definitely possible, but it's damn hard. Yeah, it will cost you a lot of time. So yeah.
So one of the downsides.
Yeah. But yeah, it's possible, and if it's crucial for you, it's crucial for the business, you would have to implement this.
Let's imagine the situation of a typical webshop where easily the most performance sensitive part is something like search, faceted search, when you tick those little boxes and choose, okay, I want this flash drive, I want it to be metal and between 64 and 256 megabytes or something. And is there anything to catch there in this kind of search scenarios? Of course, the images are somewhere in the external source already well cached.
Yeah, another great question. I think yes. You can build your system in a way that, let's say, everything about products, like little pieces, is in cache. And I can think of building the system like I will fetch the IDs of the items I need to return, and those IDs, like data for them, will be already in cache if you have a huge data set that you need to return to this. Does it make sense? Like you don't cache the response for whole searching prompt, but you will cache the pieces and build the response upon that pieces. Actually, we kind of did something similar to that.
Actually, the most performance sensitive part is not generating the response, not building the response. The part is processing the request and finding those product IDs.
Oh, so the most time-consuming part is looking up the IDs.
It's the search operation itself.
Yeah. So it depends how big and how different the search can be. Maybe we can deep dive on that later as well, because I think I won't be. I can't respond it right now in few sentences, but we can chat about it, how you can design this, so it will help you with that, definitely.
Do you have, or maybe put it in other words, I kind of missed in your presentation basically how you deal, or how is general principle to deal with the eviction based on the cache size, since we never have so many resources as you basically need, especially if you provide have some SaaS environment for a lot of users or customers, whatever. So it's inevitable that you in one day need to evict cache based on the size. So basically, in that case, the other strategies kind of are useless, since you face the eviction because of the size, and then the customer is unhappy since his performance is getting down, and basically it's not his fault actually, since he didn't change the input. And at the same time, in the SaaS, you basically face that you want to make it somewhat fair for the customers. So like, who is the one whose cache will be evicted, or how we should deal with that? Like, this is pretty complex problem we are facing also in our company. So I'm quite interested about like if you have any experiences or strategies, or even like particular products or tools to basically manage this problem.
Yeah. Thank you for the question. Interesting one. I think on the biggest service we haven't experienced such a thing, because we evict cache when it gets too big, based on the oldest things that are stored in, and see.
But the oldest one doesn't actually mean that.
Yeah, it means nothing from your point of. Yeah. But in our scenario, it means a lot, because we built the services for sports fans, and they usually went there during the playtime, or really quickly after that.
Provide some near real-time data, basically.
Yeah. So we don't have need for dealing with somehow differently. Yeah, it's pretty interesting topic. So we have little experience about caching bigger things than you can stuff into your current cache, like offloading them into some sort of bigger cache, slower cache. Still improving original data source, especially for looking up some information about users. We built kind of separate cache. You know what I'm talking, right, Kubo? And yeah, it's possible, but it's not ideal. We can talk about this, but I have no experience with really huge scale, because we didn't have to, face it.
So we basically have totally different use case.
Yeah, and we are only one of user. Like, we have the advantage that we as a developers have only one working with it.
Thank you, Pavel, again.